This program is designed to perform various tests for proportions. It reads data, it performs a one proportion test and a two proportion test and also a chi-square test. Let's look first at one proportion test. Let's assume we have 3 events in 10 trials and our null hypothesis is 50%. So we use the command prop.test, and first we have the number of events, second position, number of trials, and then p is equal to our null hypothesis. We do a two-sided test. You can see here you get the p-value of 0.26 and you can see it's 3 out of 10. Now next we do a two proportion test, so we compare two proportions. In order to do that, we have to keep in mind that how we defined x. X is a vector of counts of successes, a one-dimensional table with two entries, or it's a two-dimensional table with two columns giving the counts of successes and failures respectively. So let's look at our example. We have knockout and wild type, two groups. We have 16 successes in the knockout, 9 in the wild type, while we have 24 failures in knockout and 21 failures in wild type. First, we have to define the table. We can do this by using command matrix, and then we give the numbers, the values we need for each position, and we have to tell that we have actually 2 rows and 2 columns. Let's do that. Then by typing fix, we can look at the data. You can see it's exactly what we need. Now we do again a prop.test, and again we do it two-sided. We can see first proportion is 40%, second 30%, and we get a p-value of 0.38, which, assuming confidence level of 0.05, wouldn't be significant. So if we have questions, don't forget you can always type help to get some more information. You can see here, if you want to change from a two-sided to a left or right tail test, you can simply write less or greater. And now we can do a chi-square test. So for that we load the library mass. Maybe you also need to install it first. Then we look at the example where we have 3 different treatments: placebo, treatment A and B, and we have tumor occurrences in wild type and knockout tumors, different numbers. So we want to ask whether these numbers are the 2 factors are in dependence, that is treatment and genetic background. First, again, we have to define a table. We have 3 rows and 2 columns. Then we have to tell for each position the values. And we can also give column names and row names so that the matrix looks nicer. You can look at it. You can see here we have column names and we have row names. And then we simply perform a chi-square test. And you can see here, assuming confidence level of 0.05, it does not seem to be significant.